Hi students, let's start on the topic of differentiation, and let's see how we can actually relate what we're going to learn with the knowledge that we've already acquired from elementary mathematics, E-math. So what is differentiation? So differentiation is essentially is from this branch of mathematics which we call which is named calculus, and calculus is basically the study of continuous change, okay, between two variables or more. And generally we use it in a wide variety of application. All right, so let's see how we could actually apply this. So the first thing is I want to draw attention to what we have learned in E-math, which is gradient of a straight line is y2 minus y1 over x2 minus x1. This is also what we call about the rise over run, right? A lot of textbooks or schools, they will just say, oh, it's rise over run, or you could say that this is actually the vertical change. The rise is the vertical change over the horizontal change. Okay, that is the gradient of a straight line. Now remember, this only applies to a straight line. Okay, so let's look at what about y equals to 3. Now y equals to 3, your line actually is actually a horizontal line which looks something like that, right? So it's actually a horizontal line where this is y equals to 3. So we know that this line here, actually the gradient here is 0, right? The gradient, which is m, which is 0. This gradient has to be 0. Any straight line would be 0 because there's the run, you have infinitely long run, but you do not, your rise is 0. There's no rise. There's no rise in terms of its the line, right? So that's why the gradient function for y equals to 3, or the gradient of y equals to 3 is actually 0. Okay, that's pretty okay. Whereas let's look at y equals to 2x. So we know from E-math that actually this is y equals to 2x. This graph looks something like that, and the gradient is actually 2 very quickly. So this is m equals to 2 because the rise over run here. So this is 2. This will be 4, right? So if you put a 1 here, this will be 2. So in other words, the rise over run, if you take the rise of 1 over 2, 2 over 1 will be 2. And similarly, this gradient here would be actually 2. All right, so this 2x minus 3. Okay, so this is actually moving it down by 3 units. Translate it down by 3 units. So it looks something like that. Okay, and this will be 3 over 2. So this gradient is 2. Now, in additional mathematics, the syllabus, we're going to talk about functions which are not linear, meaning to say, what about power of 2? What about power of 3? What about ex? What about y equals to sine x? Okay, we want to find a gradient. Now, in this case here, the gradient is no longer like a fixed value, but is usually a function. And your job here is to determine the gradient function and to be able to find the gradient of each point. So what do you mean by that? Now, in E-math, we have also learned that what we can gather is, let's say, if I have got, let's say this case here. Okay, let me just refresh this first. Here, so say if we have a function like x squared minus 3, we know that we could actually use a line and calculate the gradient at this line here, right? So let's say if we're gonna find the gradient here. So what is this gradient here when x is equals to 1? All right, I've already programmed the Desmos calculator here to compute the gradient. So let me show you. This is the gradient. This is the x value that I'm using. So when x equals to 1 for this function here, x equals to 1, a is my x. X equals to 1, the gradient is actually 2. So if x is equals to, let's say, 1.5, if I were to draw a rise over run, if I were to measure it with the grid, so the rise over run here, like say this is the run and the rise. If I would take the rise over run, my gradient would be a 3. Okay, this is the gradient here, will read a 3. Okay, so the question now is, what about y equals to x squared, which is a very simple equation. So let me just show you what does it mean. We know that this gradient here, when you draw a line here, you see this is actually a horizontal line here. So I will just show you at this case here, when we were drawing y equals x squared, it will look something like that. Okay, so it looks something like that. this is y, and this is x. This is x equals to 0, right? Great. I'm going to use a very simple function here because it's easier. So when we draw a horizontal, when we try and draw the gradient in this middle, we start with the middle because that will be easier, right? So this, we know that when x equals to 0, okay, the gradient, this juncture here, the gradient would be 0, right? So that's pretty okay. When x is 0, the gradient is 0. Now, what about if I were to move to, let's say, 1? Okay, 1, the gradient here, basically, if I were to use the grid, and I'm going to measure the gradient here, rise over run, I realize that actually this registered a 2. So, in other words, this, when x equals to 1, m is equals to 2. Okay? And if you realize that the gradient is not a constant gradient because it's increasing, so this case here, when x is 2, this x is 2, I realize that my gradient is 4. So this, when x is 2, my gradient is 4. So similarly, if you were to use, like, say, sorry, this is minus 1. Okay, this is negative 1. So this is, yeah. So when x is equal to minus 1, my gradient would be, let's look at the gradient. The gradient is negative 2. And so on. Okay, as you can see, this value here double up, and conveniently I could actually write this as, this is actually 2 times 1, this is actually 2 times 2, and this is actually 2 times 0, and this is actually 2 times minus 1, right? So it's actually, when this is minus 1, this is 2 times minus 1, this is 0, this is 2 times 0, and this is 1, this is 2 times 1, 2, and this is 2. So in other words, when x equals to a, we know that my gradient would be 2 times a. Okay, so this function will work. So this is what we call, what we say when we say gradient function. Basically, this is our gradient function. Okay, in other words, this is a gradient function. If you were to use this rule here, for example, say if I were to use x equals to 3, 3 here, 3. So hard to use. Okay. So this is 6. So it's 3 times 2 give us 6, right? Okay. So obviously, please take note that this is not the only case, right? You have in the syllabus, basically we need to be able to find like other functions, like let's say x cubed, or say like x squared plus x cubed. You must be able to tell as well, like how the function changes. There's obviously another set of rule which you need to learn. Okay, but generally speaking, the study of calculus is a study of changes, right? A continuous change, and in this part of differentiation, we need to be able to find the gradient function here. And gradient function, we could write this as dy dx. Okay, I know it's a bit. And this is x, right? A is mix, so this is 2x actually. Or we could write it as f prime x. Okay, I know the first time seeing this will be very intimidating, but bear with me, it's just another notation you need to learn, right? So in this case here, this gradient here is actually 2x, or we write this as dy dx equals to 2x. Okay, so this is a general overview of why we learn differentiation. Later on, we will see how we can actually find out the gradient function without even like sketching the curve and try measuring it. Okay, so yeah, just keep practicing. Yeah, just move on to the next work example, and I will see you there.